Today we're going to be learning about using proportionality theorems. So our learning target, how can I use proportions with a triangle or parallel lines? Theorem 6.4 is our triangle proportionality theorem. So it states if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the two sides proportionally. So we have a line that's parallel to one side of the triangle, and it intersects the other two sides. So then it divides the two sides proportionally. So we can say that RT over TQ, right there, equals RU over US. The converse of the triangle proportionality theorem states if a line divides two sides of a triangle proportionally, then it is parallel. So we can set up this proportion of RT over TQ being equal to RU over US. If that's true, then we can state that TU is parallel to QS. So they're opposites. So some examples to go along with this. Number 1, find the length of YZ. So for this one, we're just going to be using the triangle proportionality theorem, not the converse. So the first theorem. So we know that we have our two parallel lines. So that splits it up proportionally. So we can say that XW over WV, XW over WV is equal to XY over YZ. Substitute numbers in. XW is 44 over WV, which is 35, equals XY, 36 over YZ, which is what we're looking for, the length of YZ. Cross multiply to solve. 44 times YZ is 44YZ equals 35 times 36, which is 1260. Divide both sides by 44 to get YZ all by itself, and we have YZ equals 28.6 if we round it. If we wanted it as a fraction, the fraction would actually be 315 over 11 would be the exact answer. All used a calculator to get, so feel free to use your calculator when doing these. All right, second example. Determine whether PS is parallel to QR. This is when we're going to use the converse. So the converse stated if we can show that the sides are proportional, then PS would be parallel to QR. So here's PS, here's QR. So we want to show that NP over PQ is equal to NS over SR. So substitute in values. NP is 90 over PQ is 50, which equals NS is 72 over SR is 40. 90 over 50 can simplify to 9 over 5, dividing both by 10. 72 over 40 can also reduce to 9 over 5 by dividing both top and bottom by 8. So since they are proportional, since our sides are proportional, we can state that PS is parallel to QR. R. Theorem 6.6, if three parallel lines intersect two transversals, then they divide the transversals proportionally. So if we have three parallel lines, like we have here, intersecting two transversals, which are in green, so transversals in green, parallel lines are in blue, then it divides the transversals, the green segments, proportionally. So we can say that UW over WY is equal to VX over XZ. So it splits up those transversals proportionally. Theorem 6.7 states that if a ray bisects an angle of a triangle, right here, this ray bisects an angle, so that means our angles here are congruent, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So it divides this segment right here, AD over DB, to be proportional to the other side. So CA over CB. So our example number 2 is going to deal with our first theorem. So I've copied it up here again so we can reference it. We want to find the length of AB, this segment right here. To do so, we use Theorem 6.6. So we have our three parallel lines. I'm going to highlight those here in red. Intersecting two transversals, our green lines. So then we can set up a proportionality statement saying that 16, this piece right here, over AB, what we are looking for, equals 15, that piece right there, over 18. Cross multiply to solve the proportion. AB times 15 is 15AB, which is equal to 16 times 18, which is 288. Divide both sides by 15 to get AB all by itself. We get AB equals 19.2. All right, last example. Example 3 goes along with Theorem 6.7, where the ray that bisects an angle divides the triangle into two proportional ratios. So in the diagram, angle QPR is congruent to angle RPS. So these two angles are congruent, which means this ray bisects that angle. So use the given side lengths to find the length of RS. So based on our theorem 6.7, we can set up a proportion. We can say that QR over RS, it's the ratio of the sides that have been bisected by the ray, these two sides, is equal to the other two sides of the triangle set up as a ratio. So QP over PS. Now we can substitute numbers in. QP is 7, PS is 13. RS is what we're looking for, which is represented by x. QR, we have to set up an expression for that by taking 15, the length of QS, and subtracting x, the length of RS. So this piece right here is actually 15, the length of the hole, right there, minus x, the length of RS. Cross multiply to find what x is equal to. X times 7 is 7x equals 13 times 15 minus x. Distribute the 13. So we get 7x equals 13 times 15, which is 195, minus 13x. Get our x's to one side, add 13x to both sides. We get 20x equals 195. Divide both sides by 20 to get x all by itself. And x equals 9.75. So we can say RS, which is what we were looking for, the length of RS, is equal to x, which we solved as 9.75. That's all the notes that I have for you today. Thank you for watching my video, and please subscribe to my YouTube channel.